Hi, and welcome to this presentation of our BCice project. In this short video, I'm going to explain what motivated this project, some of our findings and challenges along the way, as well as present the results of our testing. Initially, as a group, we were drawn towards a new and interesting method of human-computer interaction, the brain-computer interface, or BCI. The technology allows a program to monitor specific brainwave patterns of a user and react according to the readout. One of the issues currently faced with BCI is a poor recall rate, in the sense that the digital signal received from BCI hardware can often lead to wrong or no recognition on the system end. This can naturally lead to some frustration when in use. After some initial probing and participating in workshops with other project groups as well as supervisors, it was hypothesized that dynamic difficulty through a shared control system could help lessening frustration experienced when using BCI and perhaps retain motivation of the user. Now the work began of researching how such a system could be implemented. Topics researched included theory on stress, appraisal, shared control systems, interaction paradigms, and more. After a while, with most our questions answered, one thing still stood in uncertainty. Does the step size of difficulty adjustment in a shared control system affect the user frustration and motivation in a BCI game? This became our final problem statement. Unfortunately, due to events unfolding at this time, implementing and testing a prototype for BCI hardware became difficult. So, it was back to the drawing board. Somehow, we had to come up with a solution that allowed us to, at least in some way, test out the concept on participants without any physical presence or actual hardware. Fortunately, such a solution had already presented itself previously. The Hand Strengthener tool is a piece of Unity software that can produce BCI-like output with a predetermined recognition rate from a sequence of key inputs. This tool was introduced to us earlier by a supervisor who also developed it. Based on the Hand Strengthener tool, we set out to design a prototype that could serve as a platform for testing two different methods of difficulty adjustment, one with a large incremental adjustment and one with a smaller one. As you can see, the prototype consisted of a top-down ice skating game. By completing a key sequence while within an input window occurring at set intervals, the user can change the direction the skater is headed, and as such avoid collision with the walls. By recording the time it took to complete the key sequence, the system makes judgments on the performance of the user and adjusts the speed of the skater accordingly. In one scenario, the performance in the last completed trial determines the speed going towards the next one, while in the other, an average of the last 3 trials is calculated and used to judge the speed manipulation. We distributed 3 different builds of the prototype to our participants, of which there were 36. All participants were gathered online through social networking. The builds differed by alternating the order of the 2 different adjustment versions, along with a third non-adjusted version, each consisting of 20 trials each. At the end of each version, participants were tasked to fill out a questionnaire measuring their frustration, motivation, and the effectiveness of the interface. After processing the results, the verdict was in. With a p-value of more than 0.99, the hypothesis of there being a difference in reported frustration and motivation between different step sizes of adjustment was rejected. At least in the case of this prototype, there is no significant benefit to adjusting the speed of the ice skater a large amount based on multiple trials when compared to smaller amounts based on a single trial. Furthermore, there is no significant improvement to user frustration or motivation when comparing either adjustments to a constant speed. Thank you for watching.